Last Coulomb's law example problem for us. This one is example number 4 on the sheet that you got on the first day of this unit. It says, find the net force. Net means total, right? Find the total force on sphere B due to A and C. This is A, this is B, this is C. What's the net force on this guy due to the other ones? This is not unlike the last example we did, example number 3. We had 3 charges there. We wanted to find the net force on B in that one as well. But those 3 were in a row, more like this. 1, 2, 3. Ends up being a little bit easier because of that, but not much. What do you think we're going to do first here? What do you think we're going to do first in this guy? You want to find the net force, the total force on B. You need to draw a free body diagram, but only for object B. There's forces on A, there's forces on C. I don't care what they are unless you're asked to find the net force on A or C. If you're asked to find the net force on B, all we care about is the forces acting on B. Let's pretend C isn't there for a second. Just A and B. A and B are both positive charges. Are they going to attract or repel each other? They're going to what? They're going to repel each other. Good. If they repel each other, which way does B go as a result of that repulsion? Does it move towards A or does it move away from A? Away from A, so that means, Parker, it's going to go which way? Left or right? It's going to go to the right. We're going to call that FAB. The force of A acting on B is to the right. Now, we're going to pretend that A doesn't exist. Now it's just C and B. B is positive. C is negative. Do they attract or repel? They attract because it's opposite charges attracting. All right. If they attract each other, does B get pulled towards C or does it get pushed away? It gets pulled towards, which means it's going to go which way, up or down? It's going to go down. Good. We're going to call that FCB. FAB, or my fab force, or FCB, which is my force. Now, what do we got to do with these now? Find the values of these forces. We can do that. FAB is KQA QB over R squared. Good news here. We did example number 3 yesterday, and example number 3 had exactly the same charges, exactly the same distances. So the force between A and B is going to be exactly the same. It's 0.013485 newtons. The value of FCB, again, exactly the same as it was yesterday. That value works out to be 0.01198 newtons. Now, yesterday, because all 3 of these charges were in a line, when we went to add them together, we just said F net is equal to FAB plus FCB. What do we got to do here to add these forces together? You always got to add them together, right? You're trying to find a force on one charge, then you got to find all of the forces acting on that charge and then add them together. But how do we add them together here? Yes, it's exactly what we do. Draw a vector diagram, a triangle, right angle triangle, in fact. This is 0.013485 newtons to the right. This guy is 0.01198 newtons downwards. And we're going to say that the hypotenuse is the net force. And of course, that's the angle there. Whenever you have 3 charges and you want to find the force on one of them, then you've got to draw a free body diagram. And you've got to account for all of the other charges. The force of A on B and the force of C on B. If it's one-dimensional, like example number 3 was, just add them up. Pay attention to negatives. But if it's 2 dimensions like this, then you've got to do the Pythagorean theorem. F is equal to the square root of A squared plus B squared. That value, when you do that math, works out to be 1.8 times 10 to the minus 2. And theta works out to be, or is found by, using the inverse tan function of opposite over adjacent. Okay, theta works out to be 41.8 degrees. Notice for this one, I'm not saying 41.8 degrees south of east. I'm just saying 41.8 degrees. North, south, east, west is not my frame of reference. The question doesn't mention north, south, east, west like it did in most of the collision questions. So I'm just going to express it as 41.8 degrees. Or you could say, I suppose, 41.8 degrees down from right. Something like that if you wanted to. As long as you can label that angle, though, you're good for this question.